Good evening, everyone. It's the proof essayist here, and I'd like to give my thoughts overall on real analysis and how I find that if you're really to get better at it, I kind of think it would be beneficial to have a slight reform sometimes in math education where we prioritize teaching arguments of inequalities as early as high school in order to better prepare students to do proofs in actual introductory real analysis or real analysis for that matter. Because honestly, for the most part, people by the time, from my experience around middle school or high school, kind of gain the sense of balancing. They know how to at least kind of manipulate equations together and how the key idea is to go and balance one side of the equation for another when you're solving them for the like or making them the subject of an equation. But what's kind of hidden in there as an infamy, for lack of a better word at the moment, the hidden premise is that the equality sign is actually the same thing as a logical biconditional. It's two ways. You have the left-hand side and you have the right-hand side of the argument. Not only do you have to prove if this particular left-hand side is correct, then it follows that the right-hand side is the correct statement. It also follows that you have to show that if the right-hand side follows, then the left-hand side follows as well. And the thing is, there are many statements or propositions in further mathematics which can't be reducible to equations all on their own. So I think it's a lot more useful to go and teach by looking at inequalities. And yes, that will involve the writing sometimes looking a bit, I don't know if cumbersome is quite the best word to describe it, but a bit run-on. Because really, when you write an inequality argument, you're basically making a bunch of estimations and approximations all at the same moment, although with a more fine-tooth comb. You're constantly adding and making bigger numbers, eventually taking out certain terms, and you just keep going in one straight line from the left or to the right or from up to down, however you write in your language system. And it just becomes literally a chain of inequalities in one direction is how I find most analysis proofs to be in my experience. The book which I learned as an undergraduate is this one here, Understanding Analysis by Stephen Abbott. Actually, that's just the one of the books which I took and I actually liked. I actually previously took real analysis using a different book, Elementary Analysis, The Theory of Calculus by Kenneth A. Ross, and I really didn't, well, it has some merits on its own in that it covers some interesting material, but overall, as a book on exposition, it doesn't deliver. It's more like a bunch of lecture notes or scrap notebooks just added and compiled together. The thing which it doesn't do, which Understanding by Analysis does, is kind of look at the interesting stuff in analysis, which is mainly the weird stuff, the weird things that kind of present challenges to intuition and make it harder to formalize, but ultimately it's the batshit crazy stuff, like continuous everywhere but nowhere differentiable functions. Yes, they are hard, and within Abbott's own words in his preface as how he outlines the objectives of this course, I'm going to paraphrase this here. He kind of states overall with how mathematics courses at colleges need to help people prepare for the workforce in banking, medicine, law, and numerous other fields. There's kind of been a sense or a desire to teach calculus with an appeal to geometric intuition. And I think that's good so far. And in fact, I think there's not enough of it, frankly speaking. Lots of it is done through very loose hand algebra. And honestly, the more geometry, the better. But it can't be done loosely. It can't be done like just appeal to one example and think that all functions are continuous and smooth and then call it a day. You need to go and take a look at the weird counterexamples as well, which is where I think analysis really thrives in its discourse. And as he says over here, the crux of the matter is that any prevailing sentiment in favor of marketing mathematics to larger groups must at some point be reconciled with the fact that theoretical analysis is extremely challenging and even intimidating for some. One unfortunate resolution of this dilemma has been to make the course easier by making it less interesting. The omitted material is inevitably what gives analysis its true flavor. A better solution is to find a way to make the more advanced topics accessible and worth the effort. He then goes and lists these 3 goals, which are: students, especially those emerging from a reform approach to calculus, need to be convinced of the need for a more rigorous study of functions, necessity of precise definitions of the axiomatic method. But not only must they learn through them, the textbook authors and the professors have to properly motivate them. They have to be. Otherwise, you're really going to lose your connection with your audience. As usual, I think most mathematicians or real analysts will agree that if you use graphical, numerical, intuitive arguments, they need to understand as well how to distinguish that or how to robust that so it becomes a rigorous mathematical proof and how to write one. And there really needs to be a significant reward you get for firming up the logical structure of limits. There's really no point in beating a dead horse and going through rebuilding the whole thing of the limits as well, just in a new abstract but rigorous form, if you aren't going to gain anything out of it. It really doesn't help. So, as he says, the philosophy of understanding analysis is to focus attention on questions that give analysis its inherent fascination. So does the contour set contain any irrational numbers? Can a set of points where a function is discontinuous be arbitrary? Are derivatives continuous? Are derivatives integrable? Is an infinitely differentiable function necessary to the limit of its Taylor series? In giving these topics center stage, Abbott says the hard work of a rigorous study is justified by the fact that they are inaccessible without it. And yes, I will say it's not easy. I had a professor, if they don't mind having their name presented, Daniel Hurwitz, and he basically said that for our mathematics department at Skidmore, real analysis was really the hardest course to ever be offered in there. And I truly believe in that regard, because all those estimations are just crazy brain games. And then when you go and deal with the epsilon delta definition of a limit, when you go and construct the argument, the real organic thinking is to start with the statement you've been given and then reverse engineer the process to come up with the starting statement. Now, unfortunately, for lack of a better word, because we can't be bothered to read backwards to forwards, we still have to go and state those initial delta condition statements with its corresponding supremum or infimum or whatever elements you take out of the corresponding set, and then go down until you finally get that inequality which is less than epsilon in that absolute value. That's just how the convention or the standard is. But I think we really need to emphasize that, yes, there's a more organic process to it, which is hidden, and that's where I really think we need textbook authors to do a better job in conveying that to students, so prospectively analysis could get a better reputation instead of being so hard. And yes, it is hard, but this is also, in my opinion, quite interesting. And I'll leave you off with that. If you have any comments, feel free to leave them in the description. I'd be happy to entertain, I'd be really happy to engage in any dialogue, constructive or deconstructive. Any criticisms are gladly welcome. This is an open forum. This is the great thing about something as complex as like analysis, and it's also why I find beneficial about the perks of having taken a lot of philosophy courses in my undergraduate career. But yes, there goes my musings on analysis and overall how I think we need to teach inequalities, proofs using inequalities a lot more earlier on in education before we go and work with equations. So please feel free to subscribe my channel if you have not already. Until then, please have a pleasant day.